Hello students, in the last class we learnt about the classification of alcohols, phenols and ethers. In today's class, let us understand about the nomenclature of alcohols, phenols and ethers. Let us see one by one. That is, first one, nomenclature of alcohols. The common name of an alcohol is derived from the common name of alkyl group and adding the word alcohol to it. For example, let us take CH3OH. CH3OH. So to name this molecule according to common system, first write the name of the alkyl group. That is, the name of the alkyl group is methyl group, methyl, and then attach the word that is alcohol to the name of the alkyl group. That is alcohol, alcohol. So the common name of the CH3OH is methyl alcohol, methyl alcohol. In the IUPAC system, the name of an alcohol is derived from the name of the alkane from which the alcohol is derived, and by substituting the E of the alkane with the suffix OL, that is, E of the corresponding alkane is replaced by the OL. Let us take CH3OH. According to IUPAC system, first give the number of the carbon atoms. So the molecule contains only one carbon and the root word is to be represented as meth. So meth is because of the presence of one carbon atom, and the nature of the alkane, that is, it contains only single bonds, so it is to be represented as ANE. So this is the corresponding name of the hydrocarbon. Here the E is replaced by OL. E is replaced by OL. So OL indicates the presence of hydroxyl group. That is, the name of the molecule is to be written as, that is, meth, AN, and it is OL. So it is methanol. So in the common system, first to write the name of the corresponding alkyl group and then attach the word alcohol to it. And in the case of IUPAC system, the name of an alcohol is derived from the name of the alkane. That is, first write the name of the alkane by replacing E of an alkane with the suffix OL. And let us take one more example, that is CH3 CH2 OH. So to this molecule, the common name is to be written as, that is, it contains two carbon atoms, so it is an ethyl group. So the name of the corresponding alkyl group is ethyl, and attach the alcohol word to the ethyl group, that is ethyl alcohol. Then in the case of IUPAC system, so the number of carbon atoms are 2, that is, the numbering is done by the end which contains the functional group. Here the functional group is OH. So the numbering is done by the end which contains the functional group, that is OH group. And the root word is 2 carbon atoms, so it is to be represented as eth, and the nature of the carbon atoms are to be represented as ANE, and E is replaced by OL. So the name of CH3 CH2OH is to be written as ethane and OL. So it is ethanol. And the number of OH groups is indicated by adding multiplicative prefix, that is di, tri, etc. before OL. That is, if the molecule contains more than one hydroxyl group, in such case the number of the hydroxyl groups are represented by using the di, tri, tetra, etc. And the position of the hydroxyl groups are indicated by the appropriate locants. that is position of the hydroxyl group are indicated by the appropriate locants. For example, let us take CH3, C, and it is OH, so it is CH and it is CH3. So this molecule, according to common system, is to be written as, that is, the end contains the two similar groups, so it is to be represented as iso, and contains three carbon atoms, so it is isopropyl, and the word alcohol is attached. So the common system, the molecule is to be written as isopropyl alcohol. And in the case of IUPAC system, so the molecule is to be numbered by either from the left side or to the right side. That is 1, 2, 3. That is meth, eth, prop. Because of the presence of three carbon atoms, it is to be represented as pro, and it is AN, and the position of the hydroxyl group is to be represented as 2, and E is replaced by OL. So propane 2 OL, or it is also to be represented as 2 pro AN, and it is OL, 2 propanol. So propane 2 OL, or it is 2 propanol. And let us take few more examples, that is CH3, CH2, CH2, OH. So this molecule, according to common system, that is, it is common name, and it is IUPAC name. So according to common system, it is propyl group, so it is propyl, and attach the word alcohol. OH is to be written as alcohol. And in the IUPAC system, so give the number by the end which contains the functional group, so it is propane, and E is replaced by OL. And let us take one more example, that is CH3, CH, and it is OH, so it is CH2 and CH3. So the corresponding hydrocarbon is butyl, because it contains 4 carbon atoms, and the OH attached to the secondary carbon atom, that is OH attached carbon contains only one hydrogen, so it is to be represented as secondary butyl, and the word alcohol, secondary butyl alcohol. And in the case of IUPAC system, it is to be done by numbering from the end, that is left to right, so 1, 2, and it is 3 and 4. That is, second carbon atom contains hydroxyl group, that is, the root word is to be represented as bute, and the name AN, and E is replaced by OL, and the OH group is attached to the second carbon atom, and the position is to be represented as 2, and it is OL, butane 2 OL. And let us take one more example, that is CH3, CH, and it is CH3, and CH2 OH, CH2 OH. Here there is one branch, that is methyl group, and the end contains 2 similar groups. So because of the presence of 2 similar groups at the end, so it is to be represented by using the prefix, that is iso, and it contains 1, 2, 3, 4 carbon atoms. So according to common system, it is to be represented as iso, butyl, and the word alcohol. And in the IUPAC system, so So the numbering is done by the end which contains the hydroxyl group. So it is 1, 2 and it is 3. So second carbon atom contains one methyl group. So the position of the methyl group is represented as 2 and the name of the substituent group is methyl, 2 methyl and root word meth, eth, prop. So it is prop and the nature of the bonds An, E is replaced by Ol and the hydroxyl group attached to the first carbon atom. So it is to be represented as 1 Ol, 2 methyl propane, 1 Ol. And let us take one more example, that is CH3, 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 and it is OH. So according to common system, so the hydroxyl group attached to the tertiary carbon atom, that is tertiary means hydroxyl group attached carbon does not contain any hydrogens. So it is to be represented as tertiary and it contains 4 carbon atoms. So it is butyl, tertiary butyl and attach the word alcohol, tertiary butyl alcohol. And in the IUPAC system it is to be written as, that is first give the numbering, that is 1, 2 and it is 3. So second carbon contains one methyl group and also it contains hydroxyl group, that is to be represented as 2 methyl, 2 methyl and the root word is 3 carbon atoms. So it is to be written as pro and the nature of the bonds An and E is replaced by Ol, that is OH group attached to the second carbon atom and the position is to be represented as 2. So 2 methyl propane 2 Ol. That is, in the common system, first write the name of the alkyl group and then attach the word alcohol. And in the case of IUPAC system, first write the name of the corresponding hydrocarbon and then attach the suffix Ol by replacing E. If there is an substituent groups, first write the name of the substituent groups according to alphabetical order and then write the name of the corresponding root word and the name of the hydroxyl group. In the case of cyclic alcohols, that is cyclic alcohols are named using the prefix cyclo. Cyclic alcohols are named by using the prefix cyclo. Cyclo is the prefix used to the cyclic alcohols and the corresponding OH group attached to the first carbon atom. For example, let us take a cyclic ring. It is not an aromatic ring, it is a cyclic ring and the OH is attached to the carbon. So OH attached carbon is to be taken as 1, that is the first carbon atom, and the name of the molecules are to be starts from the prefix, that is cyclo, cyclo, and it contains 6 carbon atoms, that is 2, 3, 4, 5, 6. So because of the presence of 6 carbon atoms, it is to be represented as hex and nature of the bond is An and E is replaced by Ol, cyclohexanol. And let us take one more example, that is OH and it is CH3. So here there is one substituent group, that is the substituent group is methyl group. So always numbering starts from the carbon to which the hydroxyl group is attached and it is 2. So second carbon contains one substituent group, so it is methyl, 2 methyl, and the root word is hexane, and before writing the name of the number of carbon atoms, write cyclo, that is 2-methyl cyclohexane, and E is replaced by OL. So it is, and let us take one more example. So it is OH. So it contains 5 carbon atoms in the ring. So the molecule is to be written as cyclo, and because of the presence of 5 carbon atoms, it is to be represented as pent, and nature is AN. E is replaced by OL, cyclopentanol. This is the nomenclature of alcohols. Let us see the nomenclature of phenols. The simplest hydroxy derivative of benzene is phenol. That is, the formula for the phenol is C6H5OH. That is, one of the hydrogen atom in the benzene ring is replaced by the hydroxyl group, and it is its common name as well as the IUPAC name. And if the structure of the phenol involves a benzene ring in its substituted compounds, the terms ortho, meta and para are often used in the common system. That is, if the molecule contains the substituent groups, the position of the substituent groups are indicated by using the prefixes, that is ortho, meta, para in the common system. And in the case of IUPAC system, the position of the substituent groups are indicated by using the numbers, that is 1, 2 in the ortho position, and 1, 3 in the case of meta position, and 1, 4 in the case of para positions. Let us take an example, that is the first member of the aromatic compound containing hydroxyl group is phenol. So it is phenol. So both in the common system as well as in the IUPAC system, the molecule is to be named as phenol. And let us take an substituted aromatic compound. Substituted aromatic compound containing hydroxyl group. So it is CH3 and it is OH. And one more molecule, that is CH3 and it is OH, and one more molecule, CH3 and it is OH. So here the molecule, that is the first molecule in the common system, it is in the common system, it is to be written as orthocresol. That is, cresol is nothing but the aromatic ring containing one hydroxyl group and one methyl group, and both the hydroxyl group and the methyl group are present at the ortho positions. So the molecule is to be written as cresol. And in the case of IUPAC system, so the molecule is to be written as, that is, so the numbering is to be done from the carbon to which the hydroxyl group is attached. So it is 1, and the second position contains methyl group. So here select the least locant number, that is 2-methyl, and the entire molecule is to be called as phenol. So it is 2-methyl phenol. And the next molecule, according to common system, the hydroxyl group and methyl group present at the meta positions. So it is to be represented as metacresol. And in the IUPAC system, it is to be written as, that is 1, 2, 3. So third carbon atom contains methyl group. So it is 3-methyl and it is phenol, 3-methyl phenol. And the next compound, that is hydroxyl group and methyl group, present at the para positions. So it is to be written as para-cresol, and in the IUPAC system the molecule is to be written as, that is 1, 2, 3 and 4. That is 4-methyl. That is, first to write the name of the substituent group, then write the molecule, that is phenol. Methyl phenol. And let us take an example, that is the molecules which contains 2 substituent groups, that is 2 hydroxyl groups. Dihydroxy phenols, that is OH and OH. The 2 hydroxyl groups present at the ortho position, and the 2 hydroxyl groups are present at the meta positions, and the 2 hydroxyl groups are present at the para positions. So these molecules, according to common system, in the common system, so it is to be named as, that is first molecule is to be called as catechol. And according to IUPAC system, so it is to be written as, that is 1, 2. So the 2 hydroxyl groups are present, hence the molecule is to be written as benzene, and 1, 2 di-OL. That is, the prefix di is to be used because of the presence of 2 hydroxyl groups, and these 2 hydroxyl groups are attached at the first and second position. And the next molecule in the common system is to be called as resorcinol. And in the case of IUPAC system, so the molecule is written as, that is benzene, and the position of the hydroxyl groups, that is 1, 3, and it is di-OL. And the last molecule, that is the 2 hydroxyl groups are present at the para positions. So the molecule is to be called as quinol, or it is also to be called as hydroxyquinone. In the IUPAC system, the molecule is to be represented as, that is 1, 2, 3, 4. So the name of the aromatic ring is benzene, and the presence of 2 hydroxyl groups are represented as 1, 4, and it is di-OL. That is, if the 2 hydroxyl groups are present at the ortho positions in the common system, it is to be named as catechol, and if the 2 hydroxyl groups are present at the para positions, so the molecule is to be called as quinol or hydroxyquinone. If the 2 hydroxyl groups are present at the meta positions, the molecule is to be called as resorcinol. And in the case of IUPAC system, the molecules are to be written as, that is first to write the name of the benzene, and then the position of the hydroxyl groups are indicated by using the numbers, and the number of hydroxyl groups are represented by using the prefix. Let us see the nomenclature in the case of ethers. That is, common names of ethers are derived from the name of the alkyl or aryl groups, written in the separate words according to alphabetical order, and then add word ether. That is, first to write the name of the alkyl group, then attach the word ether at the end. And if both the alkyl groups are same, that is if both the alkyl groups, that is general formula for the ethers is ROR dash. If both the alkyl groups are similar, in that case the prefix di is used before the name of the alkyl group. For example, let us take CH3OCH3. So in this molecule both the alkyl groups are similar, hence the prefix di is used, and then write the name of the alkyl groups. So the alkyl group is methyl, so dimethyl, and attach the word ether, so it is dimethyl ether. And if it contains two different alkyl groups, so let us take CH3OC2H5. In this case, so the molecules, that is the alkyl groups, are written as according to alphabetical order, that is it is methyl and it is ethyl. So according to alphabetical order, E comes first, so it is to be written as ethyl, and it is methyl, and then O is to be represented as ether. So ethyl, methyl, ether. And according to IUPAC system, the ether are regarded as hydrocarbon derivative in which a hydrogen atom is replaced by the alkoxy or aryl oxy group. For example, let us take this molecule, that is the first molecule is to be named according to IUPAC system, that is the corresponding hydrocarbon of this molecule is CH4, methane. Here one of the hydrogen atom is replaced by the alkoxy group, that is alkoxy is here the methoxy group. So the molecule is to be represented as, so this group is to be written as methoxy, and the root word is meth, and the nature of the bond is ANE. So it is methoxy methane. And in the second molecule, that is it contains two different groups, hence the larger group, that is larger alkyl group, is chosen as parent hydrocarbon. So it is parent chain, parent hydrocarbon. And the entire molecule, so the remaining molecule is to be called as alkoxy group. That is, first write the name of the alkoxy group. Here the alkoxy group is methoxy, and the parent chain is 2 carbon atoms, so it is to be represented as eth, and suffix, that is the nature of the bonds, is to be represented as ANA. So it is methoxy methane. Let us take few more examples. C2H5O C2H5. So in the common system, and it is IUPAC name. So in the common system, so the ethers are to be derived by writing the name of the alkyl group. So the two alkyl groups are similar, hence it is to be named as di, and it is ethyl, diethyl ether. And in the IUPAC system, so first to write the name of the alkoxy group. Here the two alkyl groups are similar, hence so the alkoxy name is to be written as ethoxy, eth, and oxygen is oxy, and the hydrocarbon is C2H5, so it is to be named as ethane. And let us take one more example, that is CH3O CH2, and it is CH3. So one alkyl group is methyl and another alkyl group is propyl. So the two alkyl groups are different, hence the alkyl groups are named according to alphabetical order. So here the molecule starts from the letter M, and this molecule is to be starts from the letter, so it is P. So according to alphabetical order, M comes first, hence write the name of the methyl and propyl, methyl, propyl, and the and oxygen atom is to be represented as ether. So it is methyl propyl ether. And according to IUPAC system, longest alkyl group part is to be chosen as hydrocarbon. So it is hydrocarbon part, and this is to be called as alkoxy. So it is methoxy, methoxy, meth, eth, pro. So it is methoxy propane, methoxy propane. And the oxygen atom attached to the first carbon atom, hence it is to be represented as 1-methoxy propane. And let us take one more example. That is benzene ring. So oxygen, and it is CH3. That is, in the phenol, hydrogen atom is replaced by the methyl group. So in the common system, this molecule is to be named as, that is, methyl, and so C6H5O, this group is to be written as phenyl. So it is normal phenyl, normal phenyl, and ether, normal phenyl ether. In the IUPAC system, so the molecule is to be written as, that is, longest part or largest part is to be written as hydrocarbon, and the remaining part is to be called as alkoxy. So it is methoxy, methoxy, and hydrocarbon is benzene, methoxy benzene. Let us take one more example, that is CH3O and CH. So it is CH3 and it is CH3. That is, two alkyl groups are different, and the two alkyl groups names are derived according to alphabetical order. So it is methyl and it is propyl. So it is methyl, and propyl groups are present at the iso position, that is, two similar groups attached to the same carbon, hence it is to be represented as isopropyl, isopropyl, and it is ether, isopropyl ether. And in the IUPAC system, so it is to be named as, that is, first to select the hydrocarbon part. So hydrocarbon part is propyl group, and the alkoxy group is methoxy group. So it is methoxy, methoxy, and here it is not normal propane. So oxygen atom attached to the second carbon, so it is to be numbered as 1, 2, 3, attached to the second carbon atom. So the molecule is to be represented as 2-methoxy and propane, 2-methoxy propane. So this is the nomenclature for the ethers. In the next class, we will discuss about the preparation of alcohols, phenols, and ethers.